You have to compare electric field lines and magnetic field lines. Point number 1. Electric field lines start from positive and end up at negative. So for electric, point number 1, they start from positive, end up at negative. Correct. For magnetic, yes, they start from north phase, end up at south. Inside, south to north. This is point number 1. Time milega likhne vaste. Outside the body of the magnet, the direction of magnetic field lines is from north to south, and inside it is south to north. Point number 2. Electric field lines are continuous but not close. What do we mean by the term continuous? But not closed. Continuous means when I draw it, see, I need not pick this marker. If you move like this, and after that you pick it, and now restart, this is what we call as a discontinuous. And if you continue moving like this, it is termed as a continuous. So these are continuous, but not closed. Continuous but not closed. You start from point A, keep on moving, and you end up at point B. You are not coming back to the same point A. What about this one? They are continuous and closed. How? I will start from A. This is how you can draw it. Keep on moving, come back to the same position. So you start from A, end up at A. So it is continuous and close. Time with you is 2 minutes. Point number 1 and 2. Point number 3 is what? Correction is required in the notes. For electric charges, they contract. Yes? Longitudinally. What does it mean? Suppose there is a positive charge, there is a negative charge. Electric lines come from positive, enter negative. Does it mean the two will cut? No. No two electric lines can cross each other. Chapter number 1. Then what? Now you will have to modify this. Otherwise they will cut. If you modify this, then modification is of this type. So that condition that they leave the plus positive charge, enter the negative charge, that meets, and they don't cross each other. So this line has moved along this. Here also, this line and this line won't cut each other. So what is the new modified line? This one. Now, there was a line moving out, another line moving out. They move towards the length, that is along this axis. That is what we mean by the term. They contract along the length. and contract longitudinally and dilate laterally. Means what? If you have a positive charge, another positive charge, line is coming out of this, another line coming out of this. Do you think the two will cross? No. The two won't cross each other. Rather, the phenomena is like this. One, other one, two lines. They will push. They won't cross each other. They will repel. That means it is just like, it is not that they will cross each other. It is, yes, repel. In which direction? They repel along this line. That means this is longitudinal. This perpendicular direction is termed as lateral. So they repel laterally. Same is true for magnetic field lines also. How? North face, south face. If you think lines are moving out of north, moving towards south, then they will cross each other. No. They will modify in a similar fashion. Contract along the length. If there is one north, another north, one line out of this, another line out of this, will they cross each other? No. They will repel along this direction. So contract longitudinally and repel laterally. Time with you is 2 minutes to write. 2 minutes to write question number 4. Question number 5 deals with magnetic dipole moment and units are the same. Again, magnetic dipole moment, how it is defined? Natural magnet minus m plus m, length 2L. Magnetic moment is defined as capital M is equal to m into 2L. Its equivalent in electric was electric dipole moment. Charge was minus q, this was plus q, length was 2L. Electric dipole moment was charge into distance. Direction, yes, south to north. This is one way of doing it. Second, even if you have a current carrying loop, carrying current I, area is A, even then you have magnetic moment M, which is equal to what? Current into area. That's another way. But it is what? This is natural magnet and this one is electromagnet. By using a wire, flow current by using a wire. 1, 2. If the current flows through this can also work as a magnet. For this, how it is defined as current into area for 1 turn. If there are 2 turns, 2 times. If it is 1 ton, I into A. 2 tons, 2 times I into A. 3 tons, 3 times I into A. 4 tons, 4 times. If there are n tons, then n into I into A. This is one part. What is SI unit of capital M? Torque, we will prove. Whenever a magnet is placed in a magnetic field, torque is M cross B. And energy to be proved is equal to minus M dot B. If we pick this one, then units of M will come out to what? Units of U by units of B. Units of U is what? So, units of M come out to be, yes, unit of energy, joule, divided by unit of B, Tesla, joule per Tesla. This is one. SI unit, objective question, of pole strength, small m. This one, from this, capital M is equal to what? Small m into length, small m, yes, is equal to capital M divided by length. Capital M, yes, ampere into meter square, ampere into meter. I will suggest that you write complete meter. If you write M, then it is some confusion with small m. Ampere into meter square. So, capital M is what? Ampere into meter square divided by length is what? Meter. This meter cancel. What you get is ampere meter. So, what is SI unit of small m? Pole strength. Objective question. SI unit of pole strength is ampere meter. Time with you is 3 minutes to write. 3 minutes to complete.